Cool, thank you. I want to say as well, thanks to all the newbies who are coming. The first time SydJS, it's really cool to see so many people new. I'm your first experience of a SydJS talk, so no pressure at all. That's awesome. I'm going to start tonight by talking about something that really grinds my gears. The different spellings of the word color, which has come up a few times tonight. I've got a bit of a gripe with this. Most of the software we use, including the operating systems, come from America. So it can be quite frustrating to keep moving between different spellings. For patriotic reasons, my own sanity, I'll be sticking to the Australian spelling of the word colour tonight throughout these slides. So I'm Nathan Simpson. At the end of last year, I completed my design degree, and now I'm a front-end developer at ThinkMill. I absolutely love designing and building interfaces, and I've become really fascinated with how colour plays a big part of this. When working with user interfaces, or design systems for that matter, it makes sense to work off a limited palette of colors. As you use multiple shades of grays or brown colors when building interfaces, color generators are really handy. Colorbox.io, which is a project from Lift Design, is a fantastic example of this. You specify your beginning and end colors, and the app will generate X colors in between them to create a range. You can then copy the colors you've generated as JSON and chuck it into your app. This is fantastic, but I thought it'd be handy to have an alternative to this where you input one brand color and you generate multiple shades of that color. So slowly over the last couple of months, I've created Shades. Shades is a handy little web app which allows you to generate lighter and darker colors of shades of brand colors. I'd love to show you Shades now and then talk about what I learned while creating it. So let me just get set up here. Where's my screen? Over here, here we are. Cool, face this way. All right, so this is Shades. When you open it up, you've got two colors that are pre-filled here. We've got this orange color and this slate color. I'm really a fan of both of these colors. You can tweak the difference. So it's generated 11 different shades at the moment. You can tweak the difference of how dark or light the shades will get, and then you can specify how many shades you generate from that. And you can do it independently as well. So, you can have different shades over here. I can also use the system color picker. It's really hard when turning your back like this. And the things over here as well. Hang on. There we are. Sorry, you can't see that. Yeah, there we are. Okay, let me do that again. Cool. So you can choose a color. I'm just going to pick a pink or something. Cool, and hit add. And I've generated an extra color. You can add as many as you want until the interface becomes unusable. But I can then tweak the difference on here as well and generate all sorts of really cool things. And then once I'm happy creating the colors I want, I can copy them, and they're just available on my clipboard. And I'll make it so it's actual JSON, but that's just a list of colors generated at the moment. Yeah, that's about it really. You can delete them as well. It's all very fun. Let me fix this back up again. Cool. So before I go into how I built Shades, I want to quickly cover some basics on color models. So color models allow us to represent colors mathematically for different applications. We have two color methods here, additive and subtractive. So additive, you're mixing colors together to add light. So mix them together, you get that white in the middle. Subtractive is mixing inks together to absorb light. So additive we have with screens, subtractive we have on paper when you're printing stuff out. Not that we really do that here. Because we deal with web and devices, we'll be talking about color models to use the additive color method today. First one you probably think of when you think of color models is RGB. So the RGB color model mixes 3 channels, red, green, and blue, to reproduce colors. Each channel has a range of 0 to 255, and it's plotted as this cube with the X, Y, Z axis. And we can use RGB or hexadecimal syntax to represent the colors. Now, it's all a problem with RGB. So it's great for computers because, as I said before, screens reproduce colors using the RGB pixels, the additive color method. But as humans, RGB really isn't that useful to us. So we've got two colors here that are pretty similar. One's is slightly darker than the other. In the RGB column, you see that the numbers are very different. You can't really tell by looking at that, like how different they are, what's different about them, etc. Whereas with the HSL column, you can tell that they're both the same hue, the 352 degrees, and then one of them is slightly less saturated and darker than the other as well. So it's pretty easy, it's relatively easy to figure out what the differences of the colors are. So HSL is an alternative to RGB. It's optimized for artists and computer people to be able to intuitively represent and modify the colors. HSL is based on a 3-axis cylinder geometry. So around the circumference, you have your hue, which is represented in degrees, kind of like a color wheel. You have 0, which is red, 120 degrees is green, 240 is blue, and everything in the middle. You've also got saturation, which is a measure of the radius from the middle out, and that is like how intense the color is. So at 0, it's gray, there's no color coming through. At 100% saturation, it's very vibrant. And then lightness goes up from black to 50%, which is when it's the most vibrant, and then back up to 100% lightness, which is pure white. There's also HSV as well, which is slightly different with saturation and value or brightness, the HSB. If I put them side by side, you can see that very similar, just you can basically cut the HSL in half and you've got HSV effectively. The value or brightness is from 0% to 100%, and 100% brightness, the color's at its most vibrant. So, comparing HSL to RGB, these two, if you want to move between them, the two geometries are incompatible. One is a 3-axis cube, the other is based off angles. It's hard to sort of, to figure that out, to convert them. Now the way that shades works, it takes an input of RGB colors and then modifies them using the HSL model. So we need a way to convert them. They're very incompatible. So we get into some conversions. So brace yourself, I'm going to do a little bit of maths here. I'm no maths whiz by any means, but let's just go through it together. There are some great resources out there to find the conversion algorithm you need. So the first one is Hex to RGB. This one's relatively straightforward. It converts the hexadecimal notation to the 0 to 255 range. Hex and RGB contain the same information, just in a slightly different format. So I wrote this function here. It's pretty simple. At the top, you just remove the hash from the hex string. You check the length of it, if it's length of 3 or 6. You split it into channels. Where's my mouse? Can I point somehow? That'd be really good. No, I'm sorry. Splits into the RGB in channels, passes the hex string by prefixing that 0x, which you can see there. If JavaScript sees a 0x in front of a string, it will just pass it from the hexadecimal to decimal to a regular number, and then returns that as an object. Next up is RGB to HSL. This one's a little bit more involved. It's doing that geometry conversion between the cube and the cylinder. It's a lot to swallow when you first look at it. Yeah, even today it still scares me. Yeah, you get it, right? But once you sort of sit on it for a while and let it percolate a little bit, it actually transforms or copies over pretty well into a JavaScript function. So I'll skim through what it does. You don't have to really pay attention to this. It takes the input from the previous function, which is that object with the R, G, and B keys, and then converts them into a float by dividing by 255. So it's now X percentage of red, green, and blue. It gets the highest and lowest values. It generates the chroma, whatever that is. Then it goes to lightness, saturation, and hue. There's a whole lot going on here. This would have been impossible to sort of work out by myself, but thankfully, with a bit of help from the guys at ThinkMill and also with some testing, I was able to get it to work. It would have been impossible to do without testing, without a testing framework. I used Jest, which is very popular. I'd barely used it before. I thought I'd give it a go, and it really helped ensuring that the functions I was running actually produced the results I want. So to quickly cover what I did for the testing, I generated an array of objects to represent a color in different syntaxes. So each object, the orange there, it's the same orange in HSL, Hex, RGB, etc. It's the same color in all those different formats. I then wrote a test for each of those cases to make sure that the functions I was writing were grabbing the correct hue, saturation, and then the final result, which is that HSL string. After a lot of fiddling around and pulling hair out, I was able to get the test to pass, which effectively means that my conversion algorithm was actually working, which is really cool. Yeah. So once I got the actual hard one out of the way, which was converting the hex string or convert the RGB to HSL notation, we now can do the fun bit, which is generating each of the shades. So this function, generate shades, it uses the two functions we wrote before, which was hex to RGB and then RGB to HSL. So as arguments, it accepts the input color, which is your hex string, and then also accepts how many shades you want and what the bounded difference is. So how much darker or how much lighter you want your colors to get to the original. After that, just scrolling through notes here. So once we've done that, we grab our darkest color, the min, and then filter, and then use a for loop to gradually get brighter over X amount of steps to generate our hex and just make them gradually lighter. We then filter out at the bottom here any colors that have a lightness less than 0 greater than 100, because that can't really happen. And then returns the array of HSL colors ready to be converted back to RGB again. That's a whole lot of maths. I apologize. I just thought some people might find that interesting. But let's go to some JavaScript. This is how I actually built the thing. Holden's never. Okie dokie. Okay, so Shades is a basic create React app. Starts with in app.js, we have this React. Let's try and biggen that a little bit. Might be a bit easier. Cool. At the core, we have our list of our colors, which when you start Shades for the first time, you have the orange and slate color that's predetermined, and then maps through those colors to create this thing called a color set, which represents, if I skim back to Chrome for a sec, each of the rows represents a color set component, which includes the colors and the toolbar down the bottom as well. If I go into what a color set is, the color set's a smart component that has its own state within it. So you pass in the base color, and then you can set within the component, you can set how many shades and what the bounded difference is between them. And then you can pass those to the toolbar, which then has the sliders. And then once you run that function, which is generate shades, I showed you that before, creates a constant from that, and then maps through all of those colors and creates a color square, which is literally a square with the color. You may notice that I'm passing basically all the props to toolbar. The reason for that, once you can actually modify the state from the slider, but also you might notice that as you're tweaking the colors, the slider itself actually changes color. So it's grabbing it paints it with the darkest and lightest color. That was a neat little thing, just to show you, the colors that you're creating in context of where you could use them. It also shows the darkest shade, the lightest shade, and you can hit copy there as well to copy the colors to your clipboard. Alrighty. So that's about it. Okay, while I've still got the mic, I just want to quickly share with you a couple of really interesting resources that I found that if you're anything like me and enjoy playing with colors that you might find useful as well. The first one, I'll just go back to Chrome. First one, like I said before, was color box from Lift Design. So you can change, if you've got two colors beginning and end, you can change the hue, saturation, and lightness of those colors. And what's really cool about this as well is, if I make a bit of difference here, you can view the graph that's generated between both ends, and you can change the pace of which these colors are changed. So there's a regular linear chart between the two. You can also go like a sine wave, ease in, and then you can really go to town and find some really interesting combinations. And then you can hit share at the end and copy the JSON from that as well, which is really cool. Another resource is, I'll tweet all these as well, so you can grab a link on my profile. Another one is called Color from Quix or something. It's a package that you can download. I'm big in that a little bit as well. You create a color, pass in a hex string, RGB, whatever you like, and then you can adjust the alpha, you can adjust the light, you make it lighter, make it darker, change the hue, all the rest of it. In case you don't want to make your own RGB to HSL conversion library, you can use that as well, which is really cool. And then someone on the Aussie Designers Slack shared this the other day, which was really useful. It's a command line tool that you specify, you give it a certain color, you can change the notation from hex to HSL or whatever, you can rotate the hue, you can do all sorts of things. It's a nice little UI for manipulating colors within a command line, which is really cool. And then finally, a resource that I feel really strongly about, I really like these guys, Refactoring UI. Adam Wathan, is that how you say his name? Yeah. Adam Wathan and Steve Scherger, a little project they made together called Refactoring UI. They started with sharing some design tips on Twitter. This is a really good example about, try saturating your grays with a bit of blue or brown for a cooler, warmer feel rather than just a basic gray. But they've sort of buttload of really cool design tips on Twitter. They've released articles. They've done screencasts on YouTube where they redesign an app using some really cool design ideas. And then recently they also released an ebook as well where you can learn everything they know about colors and design. And then there's also some really cool videos along with it as well. I'll share all those on my Twitter, so if you're interested, you can grab a link to them. Cool. So if you want to play with shades, there's the website. You can check it out. Also, if you want to connect with me, that's my website there. And also, I'm Nath J. Simpson, basically everywhere. Yeah, that's it. Thank you very much.